Hey everyone! Welcome back to the channel where we dive deep into the science, history, and surprising stories behind the everyday things that shape our world. Today, we're embarking on an epic adventure, one that traces the remarkable journey of plastics, from their humble beginnings to the cutting-edge innovations of today. Take a look around you right now. Chances are, you're surrounded by plastic. Maybe it's the chair you're sitting on, the pen in your hand, or the device you're watching this on. Plastic is everywhere, seamlessly woven into the fabric of our daily lives. But have you ever stopped to wonder how this material, so common and yet so complex, came to be? From the moment you wake up and brush your teeth with a plastic toothbrush, to the time you scroll through your phone before bed, plastics are your silent companions. They keep your food fresh in airtight packaging, make your car lighter and safer, and even help deliver life-saving medicines. Plastics are the invisible threads that connect modern convenience, safety, and innovation. But what exactly is plastic? How did it become so essential, and what makes it so incredibly versatile? Why can it be soft and squishy in one form, yet tough and rigid in another? Today, we'll unravel these mysteries and discover the science and ingenuity that transformed plastics from laboratory curiosities into the backbone of modern civilization. So buckle up, because I'm about to pull back the curtain on this extraordinary invention. We'll journey through its origins, dive into the chemistry that gives it life, and explore the groundbreaking innovations that are shaping the future of plastics. At its core, plastic is made up of long, repeating chains called polymers. Imagine a bowl of spaghetti, with each noodle representing a chain of molecules linked together. These molecular chains can be twisted, stretched, and arranged in countless ways, giving plastics their astonishing range of properties, from flexibility and transparency to strength and resilience. Most of these polymers start their journey deep underground, derived from petroleum or natural gas. But the story doesn't end there. Scientists have learned to extract polymers from plants like corn and sugarcane, and are even experimenting with algae and other renewable sources. Imagine a future where your plastic water bottle could be made from a field of corn or a tank of algae. The magic begins with tiny molecules called monomers, the building blocks of all plastics. Picture them as beads on a string. When these monomers are linked together in a process called polymerization, they form those long, flexible chains that give plastic its unique character. During polymerization, these monomers snap together like Lego bricks, creating chains that can be hundreds or even thousands of units long. By carefully controlling this process, chemists can design plastics with just the right balance of strength, flexibility, and durability, tailored for everything from cling wrap to bulletproof vests. That's why plastics can be so tough, bendy, or even crystal clear. Engineers can tweak the recipe to make plastics that are soft and squishy like a rubber duck, or hard and impact-resistant like a football helmet. The possibilities are nearly endless, limited only by our imagination and ingenuity. But not all plastics are created equal. There are two main families, thermoplastics and thermosets, each with its own set of superpowers. Thermoplastics can be melted and reshaped again and again, while thermosets lock into place forever once they're formed. Thermoplastics are the ultimate recyclers. Heat them up and they become soft and moldable, perfect for making bottles, bags, and even car parts. When you toss a plastic bottle into the recycling bin, it can be melted down and reborn as something entirely new, over and over again. Thermosets, on the other hand, are the strong, silent types. Once they're set, they stay solid and unyielding, even under intense heat. This makes them ideal for things like electrical insulators, kitchen countertops, and high-performance adhesives, places where strength and stability are a must. Classic examples include Bakelite, the world's first synthetic plastic, and epoxy resins, which are used in everything from electronics to aircraft. Bakelite revolutionized the world of consumer goods, making radios, telephones, and even early computers possible, ushering in the age of mass production and affordable technology. But how do we transform raw resources into the plastic marvels we use every day? The journey begins with extracting oil or gas, which is then refined and broken down into simple molecules. These molecules are the seeds from which all plastics grow. In massive refineries, crude oil and natural gas are separated into their basic components, like ethylene and propylene. These are the monomers, the essential building blocks that will soon become the backbone of plastic products. Through the magic of polymerization, these monomers are linked together to form long, sturdy chains. This is where the transformation happens. Simple gases are turned into solid, versatile materials that can be shaped into almost anything you can imagine. There are two main ways to build these chains: addition polymerization, which creates everyday plastics like polyethylene and polypropylene, and condensation polymerization, which gives us strong, durable materials like nylon and polyester. Each method produces plastics with unique textures, strengths, and uses, from soft fibers in your clothes to tough casings in your electronics. But the story doesn't stop there. Manufacturers add special ingredients called additives to give plastics their superpowers. These additives can make plastics more flexible, colorful, or resistant to heat, sunlight, and even bacteria. Without them, most plastics would be brittle, dull, or quick to degrade. Once the perfect blend is achieved, plastics are shaped using high-tech processes like injection molding, extrusion, and blow molding. These techniques allow us to create everything from tiny gears in your watch to massive water tanks, with incredible precision and efficiency. Additives are the secret sauce that make plastics so adaptable. Some can make plastics glow in the dark, others can help them conduct electricity, and some even make them resistant to germs, perfect for medical equipment and food packaging. Plasticizers make plastics soft and bendy, stabilizers help them survive harsh sunlight and heat, and flame retardants keep them safer in case of fire. Each additive is carefully chosen to match the job, ensuring that plastics perform exactly as needed, wherever they're used. Reinforcing agents like fiberglass take plastic strength to a whole new level. These composite materials are used in cars, airplanes, and even spacecraft, making them lighter, stronger, and more fuel efficient. Thanks to these innovations, we can travel farther, faster, and safer than ever before. The story of plastic is filled with moments of inspiration and discovery. For over a century, inventors and scientists have experimented with new formulas, each breakthrough opening up new possibilities and changing the way we live, work, and play. In 1907, Leo Baekeland created Bakelite, the world's first fully synthetic plastic. This invention revolutionized manufacturing, making it possible to produce affordable, durable goods for the masses. Radios, telephones, and kitchenware suddenly became accessible to everyone, sparking a wave of innovation that would shape the 20th century. During World War II, plastics like nylon and plexiglass became heroes in their own right. Nylon replaced scarce silk in parachutes, saving countless lives, while plexiglass provided lightweight, shatter-resistant windows for airplanes. These innovations helped turn the tide of war and proved the incredible potential of plastics. After the war, plastics exploded into everyday life. Tupperware parties brought convenience to kitchens, vinyl records filled homes with music, and colorful gadgets made life easier and more fun. The plastic age had arrived, transforming society with affordable, innovative products for all. Today, plastics are everywhere, from sterile medical supplies that save lives, to lightweight car parts that improve fuel efficiency, to the high-tech gadgets that connect us to the world. Plastics have made modern life safer, healthier, and more connected than ever before, but the journey doesn't stop here. The plastics industry is constantly evolving, with researchers inventing new materials that are smarter, safer, and more sustainable. Imagine plastics that heal themselves, change color, or even biodegrade after use. Bioplastics, made from renewable resources like corn and sugarcane, are leading the charge toward a greener future. These innovative materials aim to reduce our reliance on fossil fuels and help tackle the global challenge of plastic waste. Scientists are working tirelessly to create plastics that do their job, then break down safely and cleanly when they're no longer needed. Imagine a world where your plastic bag or cup disappears harmlessly after use, leaving no trace behind, just nutrients for the earth. So next time you pick up anything plastic, take a moment to appreciate the incredible journey behind it. From deep underground to the laboratory, from the factory floor to your hands, every piece of plastic carries a story of science, innovation, and human creativity, and maybe, just maybe, a vision for a cleaner, greener future. If you enjoyed uncovering the secrets of plastics with me, don't forget to hit like, subscribe, and ring that bell for more science-packed adventures. Your support helps us keep exploring the amazing world around us, one discovery at a time. Thanks for watching, and I'll see you in the next one. Until then, stay curious, keep exploring, and remember, the story of plastics is still being written and you're a part of it.